Hello, students. So today's topic, we're going to be learning about parallel lines and transversals. So yesterday's topic was a bit long. We had a lot of new terms and new relationships to practice, which is why the assignment was a bit longer than usual. So if you need some extra time today to finish that assignment, then no worries. Go ahead, take your time and work on that assignment, because today's isn't quite as long. You see, yesterday we learned all of those new terms and things, and today we're going to learn why we learned about them, and we're going to learn the special relationship about them. So let's just recall from yesterday what a transversal is. So that was a line that intersected two or more lines. And also, we need to remember about parallel lines. So this is something you've probably been learning about since middle school, maybe earlier, I don't know. And these are two lines that have the same slope, and that means that they never intersect. So AB and CD are both going to keep going on and on forever, and they're never going to meet. And that creates some pretty special properties between the two. And of course, it's always good to remember what a linear pair is. These are two angles that are both adjacent and supplementary. So let's get started. Página 14. Today is the 16th. So in the last lesson, we learned how to identify different types of angles formed by a transversal. We learned about corresponding angles, which were the angles that were in the same position on the transversal. So like 1 and 5, because they're both in the top left corner of their intersection. Then we learned about alternate interior angles, which are angles on the interior and on opposite sides that are non-adjacent, so 4 and 6. Alternate exterior angles, which similar to the one right before, but they're on the exterior, so 1 and 7. And lastly, we learned about same side interior angles, which are, well, angles on the same side of the interior. But we didn't really learn what was so great about them. We just learned that they have that name, that 4 and 5 are called same side interior, but it didn't mean anything to us. Well, that's because some very special things happen when two parallel lines are cut by a transversal. Grab a pen that I left in my backpack. All right. So when two parallel lines are cut by a transversal, the angles formed should say have a special relationship. Realizing midway through a lesson that I forgot something. That's okay. That's something for me to deal with later. All right, so here I have drawn a pair of parallel lines, and we're going to slice it by a transversal. So before, it didn't matter if the lines were crooked or anything like that, as long as we had two lines and a transversal. But now we're dealing specifically with two lines that are parallel. So just real quick, I'm going to trace over two of the angles formed. And I'm going to demonstrate something very fascinating. I really should have this stuff prepared beforehand, but we live and learn. So I'm going to call one of these angles A and the other B. So I picked out B from up here. It's sticking to my fingers, sorry. And A fits here. Please stop sticking. Of course, this is a crude representation. So we may notice that there's something interesting about this. So we know that vertical angles are congruent, so this B should also fit in the angle across from it. And it does. So cool, vertical angles are indeed congruent. But what about here? Interesting. So the angle B from up here is the same as this angle here. The corresponding angles are exactly the same here. And of course, we know that vertical angles are congruent, so this angle also fits here. But it also fits down here. Alternate exterior angles. They're the same. And this is a very small representation. If we put them together, what do you know? They're forming a straight line together. So A and B are supplementary. So there's a lot of really neat relationships going on here with these parallel lines and the transversal. All of the angles are going to fall into one of two categories. They're either going to be A or they're going to be B. All of the A's are going to be equal to each other. All of the B's are going to be equal to each other. And A and B together are going to be supplementary. So let's put that in some words. So corresponding angles, like when I placed angle B right here and right here, we found it was the same angle. So corresponding angles are congruent. Alternate interior angles are also congruent. And then we did the alternate exteriors, which were the same. And lastly, we had shown that the same side interior angles were congruent, or excuse me, supplementary. So, why does this matter so much? Well, boy, am I glad to tell you. If you know one angle measure, wow, I cannot spell. All right, let's try that again. There we go. If you know one angle measure, you can find all 7 other measures. And it makes sense because, for example, if I know angle A is 120 degrees, then all other corresponding alternate interior and alternate exterior angles are also 120 degrees. And then if I do 120 subtracted from 180, I would find out that B is 60 degrees. And then all of B's corresponding alternate interior and alternate exterior angles would be congruent, and they would be 60 degrees. So every single measure of this up here would be either 120 or 60 degrees. And if you look, all of the acute ones would be 60, and all of the obtuse ones would be 120. So those patterns that we were recognizing yesterday are so important because it makes your life so much quicker and easier to be able to look at this and understand that even if you only know one of the angle measures, you can figure out all of the other ones in a flash. And of course, it's important to remember that vertical angles are always congruent, and linear pairs like 4 and 3 are also always supplementary. So let's do an example where I walk you through. And of course, your drawings don't have to be perfect or anything like that, even when we're dealing with something like parallel lines, because this is for your notes. So we're going to be given that the measure of angle 1 is 55 degrees. And we need to find angle 2, 3, 4, 5, 6, 7, and 8. And normally that would be quite a task. You'd be like, that is way too many angles to figure out. But they're all either going to be 55 degrees or 180 minus 55. Now I'm going to take this kind of the long route for the example, but once you see the pattern, it should go a lot quicker for you. So I usually pick out a few angles to go through, kind of the easiest path, because there's a lot of different paths I could take to filling in all of the measures. But, excuse me, I'm like hoarse today. I'm going to go through it one by one so we can see all of the different relationships happening. So angle 1, which is 55, and angle 2 form a linear pair. That means that the measure of angle 1, or rather, I don't know why I wrote and there. The measure of angle 1 plus the measure of angle 2 will equal 180. So in order to find 2, I would do 55 degrees plus whatever the measure of angle 2 is equal to 180 degrees. And I would subtract 55 from both sides to get the measure of angle 2. It's 125 degrees. So now I know the two different numbers I'm going to use for this whole paper. Now I'll keep going in order. So that was 2. The measure of angle 3 is equal to the measure of angle 1 because they're vertical. So the measure of angle 3 is 55 degrees as well. Trying to figure out how to organize this a little better. The measure of angle 2 is also equal to the measure of angle 4 because those two are vertical. So the measure of angle 4 is equal to 125 degrees. If you're picking up on the pattern, should start going a little quicker in the brain. Oops, I'm going to need to move this forward a bit. There we go. All right, so we have the first 4 angles figured out. And now we just need to figure out these. Normally, our problem would arise that, well, I was able to use linear pairs and vertical angles to figure out those 4. But otherwise, I would have no way because none of these are vertical or form linear pairs with these. So what we learned yesterday enables us to figure out what these are as well, because I would be able to see relationships like corresponding alternate interior, alternate exterior, and same side interior. And we're going to use those to continue. So again, going in order, the measure of angle 1 and 5 are corresponding angles. According to up here, corresponding angles are congruent. So the measure of angle 1 equals the measure of angle 5, meaning that the measure of angle 5 is equal to 55 degrees. So I'm going to go up here and fill in 55 there. And then there's a few ways we could solve for 6, but I'm going to demonstrate some different varieties. So we could do the linear pair, but what if we do the alternate interior angles? 4 is 125, and it's an alternate interior with 6, and alternate interior angles are congruent. So that means the measure of angle 4 equals the measure of angle 5, because these guys are alternate interior angles. Or I'm sorry, the measure of angle 4 equals 6. And the measure of angle 6 would be equal to 125 degrees. I know this is a bit long and a bit messy. We're just taking it one piece at a time. The typed notes are a little bit more organized if you prefer. I just thought I would throw that in because this is a little bit of a disaster on my notebook page. Okay, but we only have 2 left. So 7, well 7 has a few different ones. You could either say it's corresponding with 3, or it's an alternate interior with 1, or it's vertical with 5, or it forms a linear pair with 6. So notice they're all connected to each other. So as long as you're able to find one of those to use, you're golden. I like to use vertical angles because they're so simple, but let's do alternate exterior because we haven't touched on that one. So the measure of angle 1 is equal to the measure of angle 7 because they're alt exterior angles. So the measure of angle 7 will also be equal to 55 degrees. And the very last one, come on, I bet you can guess it already. We're left with 8, which is corresponding with 4, alternate exterior with 125, vertical with 125. So the measure of angle 8 has got to be 125 as well. Think about what I said before. All of the obtuse angles are 125. All of the acute angles are 55. So we have a lot of really awesome relationships happening here that make our work so easy. So again, I just want to let you guys know that there's a more organized version of this where I go through the first 4 up here and then the last 4 up here and talk about it here. So the pattern you see here will be the same for every pair of parallel lines cut by a transversal. The angles in, okay, it says red, but this printed in gray. So the angles in red, which were 55, will always be congruent, and the angles in blue will always be congruent. Now, it's not always going to be 55 degrees and 125. You have to pay attention to the angle they give you. But those relationships, the fact that they're congruent, will be the same. And also, all of the different angles, so 125 and 55, will always be supplementary. So the acute and the obtuse will always be supplementary. So your best medicine is watching lots of examples and practicing the problems. I'm going to upload a fair bit of videos for you guys to help you out for today, but I think that the pattern, once you practice it a little bit, should start to pop up for you. All right, that's all I got for today. I will catch you next time.